Quadratic word problems, Algebra 2 trigonometry regions. Vanessa throws a tennis ball in the air. The function h of t equals negative 16t squared plus 45t plus 7 represents the distance in feet that the ball is thrown from the ground at any time t. At what time to the nearest tenth of a second is the ball at its maximum height? So this is really more of a physics question than anything, but it is what we're doing. And so we see it's a quadratic, and this is our quadratic chapter, so you see that. But notice that they're using this function notation, which we will discuss more of later on, but you could think of it kind of like y equals. And these t's you could think of kind of as x's. Basically, for our x and y axis here, they're saying that the x-axis, which is normally our x-axis, would be t. Excuse me 1 second. So as I was saying, the x-axis for us is normally x, but they're saying t, and that would be time here. And then the y-axis, they're saying is height. So you throw a ball up in the air, eventually it comes down, and this is forming a parabola. And there's really two things that we do with these quadratic problems. Is we want to know often the maximum height, and if it were like this, then it would be the minimum. But we want to know the maximum, which is what this problem is asking for, the maximum height. And sometimes we want to know how long until it's going to hit the ground, which would be here, and that would be what we call a root. And we'll see one of those in this video, one of each of those. And let's talk about a maximum. But this whole concept of the quadratic word problem, we're going to do all of this work in our calculator. So just labeling my picture here is the maximum. I throw a ball up in the air, it goes to maximum height. So you need your calculator for this. So the first thing we're going to do is we're going to type the equation they give us into our y equals screen. So that would be negative 16, and we're going to do x squared, even though it's saying t, but it's talking about the x-axis, plus 45x plus 7. And the way you always want to graph on this calculator is you always want to start, you don't hit graph instead, because we're going to be playing with our graph settings in this. So the way to always go back to the default graph, the normal looking graph, is if you hit zoom and then the number 6, and you'll see 6 is standard. So hit zoom 6 will get you to your standard zoom. All right, so how come my picture doesn't match up? And that's part of what makes this topic challenging, is being able to play with my calculator window so that I could get a picture similar to what I have drawn over here. And so you'll notice a couple of things. Notice that it's you can kind of tell what's happening here is it's going up, up, up past our screen, and then it's coming back down. So our calculator screen is not high enough on the y-axis. But notice the x-axis. I have all this wasted space over here to the left, which makes sense because if that's time, this would be considered negative time. So we really don't need this negative side of our x-axis. And then the positive side of our x-axis, we see that it's crossing around what looks like to be 3, but then this is all wasted space here. So if you click on Window, which is up top, the first thing it asks for is an x min and an x max. And so that's our x-axis, our time axis. And I'm going to set it to the minimum to 0 because I don't need any negative time in this problem. So I'm going to set it to 0. And my max, I could leave it at 10 if I want, but I'm going to set it to, I don't know, let's say 6, just so I don't have all that extra space over there. And then take a look at the graph from there, and you'll see that it's a little bit better on this side, but I'm still missing what's up top. I'm still missing the curve part of it. But I do like what we have down here. And again, I set my x to 6. I probably could have set it to, I don't want to go all the way to 3. I want to have some space over here, but 4 or 5 or 6, anything like that is fine. But my real issue right now is I need to see the curve on top. I need to see the maximum because that's what this question is asking about. And so that's our y-axis. So again, I'm going to go back to Window. And the third thing down, XSCL, stands for X scale. Don't change that. Leave that at 1. Never play with that. We're only going to change the min-max features. So my y minimum is the part below my y-axis. And again, I really don't need much of that. So I could leave it. The only reason I'm not going to put it to 0 is, well, I could put it to 0, but I'm going to just leave it for now. It's not going to really harm anything, just leaving it. But the Y max, that's how high your graph goes. And so that's what needs to be adjusted. And you don't want to change it to 12 and then 13 and then 15. It's best to kind of do a big jump, see if you see it, and then you can always scale back. So what I always start off with is 100. Jump right to an X max of 100, and let's see what that does. And there we go, we see it. So 100 has a lot of wasted space. So now I could deal with what I have here, but I'm going to scale that back a little bit to get a nicer picture. And let's go with 50, about half of what I have. And that is a pretty good picture right there. And again, I could change. I could cut out some X. I could deal with that. I don't really need negative Y here, but this is good enough. And so this is my picture right here. And so the maximum of this is here. And so I need to know this coordinate, okay, the maximum of this. And so the way, again, our calculator is going to do that stuff for us, but the way we're going to do it is in the, see this button over here on the top row where it says trace, but above it says calc. That's what we want. So if we hit second trace, it brings us to the calc feature. And this is where you're going to do a lot of stuff for this chapter. And the first thing I want is for this is maximum. So I'm going to choose the number 4 that says maximum. And then what you'll see on your calculator is you'll see this little bug looking thing. It's a box with an X through it flashing. And that's where your cursor is. And you're going to use the left and right buttons to move that around your curve. And what we have to do is it's asking us a question left bound. And what that means is it wants us to go to the left of it. Now the maximum is probably about here, but that's not necessarily the max, but it's close. I want the exact, and my calculator will do that, but you have to set a narrow window. So we have to first go to the left of it. So see that I put my bug symbol to the left of the maximum, hit enter, and now it's asking for right bound. So now I need to go to the right of the max. So the max is here, a couple clicks to the right, hit enter. Once you have both of those arrows up there, it asks you, do you want to guess? And you say yes by entering again. So enter another time. You don't need to move anything. You just hit enter again. And it'll calculate the maximum for us of this. And so here is my maximum. And here's my X value, here's my Y value. And remember, X value in this question would be a concept of time, T. Just move this over a little bit. And my Y value, so this is your time, and this is your height. And we want the maximum height. And so that's our Y value. And so to the nearest tenth of a second, the answer would be 38.6. That would be the maximum height, the Y value. And if I wanted how long until it gets there, it would be 1.4 seconds. If time is in seconds, it should say up here what time is. But that's really not what this question is asking for. But it's asking for distance in feet. So this would be 38.6 feet. All right, let's look at one more quick question. But this time, it'll be not how high does it go, but how long until it hits the ground. And that would be this feature right here. Or I guess I could just do that with this problem here. And so I want to know how long until it hits the ground. How much time passes before this ball hits the ground here. And so what I do is I keep my window here, but this time I want to know what this point is, where it crosses the x-axis. That's when it hits the ground, because the ground is, height 0. And so for that, I kind of want to see a little bit of space here. So that's why I kept my y minimum in here, and I'm actually going to increase that to -20, because I want to be able to see above and below the axis for this problem. And so this is what I'm looking for, is this spot right here. And so I go back to second calc to trace, and this time I choose choice 2, 0, because it has a height of 0. So choice 2. And again, it's asking left and right. And so it puts me close to that spot, but it doesn't always do that. Sometimes you need to move to the spot, but I want to go to the left of it. So maybe 3 clicks to the left of it, hit enter, and then go back to it, and a couple, 3 clicks to the right of it, hit enter twice, second one is because you want it to guess, and we'll give you this value here. And so this is my coordinate for here. Now notice that the y value should be 0. They're giving us a number like this, but you could just pretty much say rounds to 0. That'd be like 0.000000. So it's basically good enough. But this is when it hits the ground, and this is my time. So this will hit the ground in 2.96 seconds. Now the problem should specify how long the time is. Distance in feet, ball's thrown t, what is the maximum height? It's the nearest tenth of a second. So yeah, they're talking about time in seconds. So the x value is our time for this problem. So like in this next question, I'm not going to do because we're out of time. It says, how long till it hits the ground? I would type this into my calculator, play with my window until I had this picture, and then I would use the 0 function, the second calc 0, to get this value right here on my screen. And I'm for time, I'm looking or for the x value. For height, I'm looking for the y value. And so that's what we're going to practice tomorrow in class. Make sure you definitely have your calculators tomorrow in class, because that's definitely a necessity to accomplish